Hello dear students, in this video we will see the previous year questions and questions from sample papers from chapter 4 probability distributions. Now these are the questions from last year's term 1 board paper. If m is the mean of Poisson distribution, then its standard deviation is given by. Now we know that in a Poisson distribution the mean of x, it is equal to the variance of x. Here we are asked to find the standard deviation. So standard deviation, it is nothing but it is root of variance. Here mean, it is given as m. So the mean is equal to variance, it is equal to m. And now standard deviation, it is root of variance. So it is equal to root m. So the correct option is option A. Next question, the normal distribution curve is symmetrical about. So the normal distribution curve, if you could recall, it is a bell-shaped curve and it is symmetrical about the mean. That is x is equal to mu. So here we know that the normal distribution curve, it is symmetrical about the mean mu. The meaning is that it divides the entire area into two halves. So this side we have half the area and this side we have half the area. So the correct option is option A. X is equal to mu. Next question, let x be a discrete random variable whose probability distribution is given below. So here x is a discrete random variable and its probability distribution is given below. That is, when x is 0, the probability is 0. When x is 1, the probability is 2k. When x is 2, then the associated probability, it is again 2k, and so on. Now we have to find the value of k. Now we know that if x is a discrete random variable with a given probability distribution, then the sum of all these probabilities will be equal to 1. Summation probability of x is equal to xi. This is equal to 1. So from this we have 0 plus 2k plus 2k plus 3k plus k square plus 2k square plus 7k square plus 2k. This is equal to 1. So here 2k plus 2k, 4k, 7k, 9k plus 10k square equal to 1, or this is a quadratic equation in k which can be solved. So 10k square plus 9k minus 1 is equal to 0, or this we can write it as 10k square plus 10k minus k minus 1 equal to 0, or we have 10k into k plus 1 minus 1 into k plus 1 is equal to 0. So from this we get 10k minus 1 into k plus 1 equal to 0. From this we get k equal to 1 by 10 or k equal to minus 1. Now this is not possible, because if we have k as minus 1, then here we will have negative probability, which is not possible. Therefore k equal to 1 by 10. The value of k is 1 by 10. The correct option is option A. Next question, in a box of 100 bulbs, 10 are defective. What is the probability that out of a sample of 5 bulbs, none is defective? So here we have a box of 100 bulbs in which 10 are defective. Here we have to find the probability that in a sample of 5 bulbs, no bulb is defective. So here let us take, let x be the random variable, the number of defective bulbs in 5 bulbs. So here x is a binomial distribution with parameters n equal to 5, and probability of success is probability of defective bulb. So here n equal to 5 and probability of a defective bulb is 10 by 100, or it is 1 by 10. And now we know q is equal to the probability of failure, it is 1 minus p, which is 1 minus 1 by 10, 9 by 10. Therefore X follows binomial distribution with parameters 5, 1 by 10. Now we have to find the probability that none is defective. Now we know that probability of R successes, it is given by NCR P raised to R Q raised to N minus R. We need to find probability of X is equal to 0. So it is 5C0, then P is 1 by 10, 1 by 10 raised to 0, Q is 9 by 10, 9 by 10 raised to 5 minus 0, which is 5. So 5C0 is 1. This is 9 by 10 the whole raised to 5. So the correct option is option A. Next question. If X is a normal variate with mean mu and standard deviation sigma greater than 0, then the new random variate Z equal to X minus mu by sigma is a variate with. So this is also a familiar feature of standard normal variate, which is Z given by X minus mu by sigma. So here the new normal variate Z has mean equal to 0 and standard deviation equal to 1. So the correct option is option D. Next question, the mean expectation of X of the numbers obtained on throwing a die having 1 written on 3 faces, 2 on 2 faces and 5 on 1 faces. So here we have to find the expectation of numbers that is obtained on throwing a die in which 1 is written on 3 face, 2 on 2 face and 5 on 1 face. So let us take, let X be the random variable number obtained on the die. So the various values which X can take are 1, 2 and 5. So because we have 1 written on 3 faces, 2 and 5 written on respective faces. Now we have probability of X equal to Xi. It is, that is probability of getting a 1 is number of favorable outcomes divided by total number of outcomes. So it is 3 by 6 because 1 is written on 3 face. Then probability of X is equal to 2 is, here 2 is written on 2 face. So number of favorable outcomes divided by total number of outcomes. It is 2 by 6 and 5 is written on 1 face. So probability of getting a 5 is 1 by 6. Here we have to find expectation of X. Expectation of X is summation Xi Pi. So this is Xi and this is Pi. So it is 1 into 3 by 6 plus 2 into 2 by 6 plus 5 into 1 by 6. So here 6 is the LCM. Numerator we have 12. So this is 12 by 6, which is 2. So the correct option is option B, 2. Next question. Let X represent the difference between the number of heads and number of tails obtained when a coin is tossed 6 times. Then the possible values of X are. So here we have a random variable X which represents the difference between the number of heads and number of tails obtained when a coin is tossed 6 times. We have to find the values which X can take. So here when a coin is tossed 6 times, the various outcomes that are possible are either we can get 0 head, 6 tail, 1 head, 5 tail, then 2 head, 4 tail, 3 head, 3 tail, or 4 head, 2 tail, or 5 head, 1 tail, or 6 heads, no tails. So these are the various outcomes. Here it is given X is the difference between number of heads and number of tails. So here X will take values 6 minus 0, 6, 5 minus 1, 4. That is the difference between number of tails and number of heads. So this is 6 minus 0, 6. So here it is 5 tails, 1 head. So 5 minus 1, 4. Here it is 4 tails, 2 heads. So here it is 4 minus 2, 2. Here 3 minus 3, 0. Again 4 minus 2, 2. 5 minus 1, 4. 6 minus 0, 6. So the various values which x can take are 0, 2, 4 and 6. So the correct option is option B. Next question, the mean of a binomial distribution is 81. Then the standard deviation lies in the interval. So here the binomial distribution, the mean is given as 81. We have to find the interval in which the standard deviation will lie. So let us assume x follows binomial with parameters n and p. Then the standard deviation sigma, it is given by root of npq. Now this sigma, it is greater than or equal to 0. And now we have the mean of binomial distribution, it is equal to np. This is given as 81. So the mean is given as 81. And we know that if x follows binomial distribution, then the variance, it is given by npq. And we have this q, it is less than 1. That is the probability of failure, it is less than 1. So from this we get npq, it is less than np. Here since we are multiplying this np with q which is less than 1, we will get npq less than np. So from this we get npq less than 81. If we take root on both sides, root of npq, it is less than root 81. Or root npq, it is nothing but it is the standard deviation sigma. Sigma is less than 9. So if we take this as 1 and this as 2, 1 and 2 implies 0 less than or equal to sigma less than 9. So the standard deviation lies in the interval close to 0, open 9. The correct option is option E. Next question, if a random variable x has the Poisson distribution with mean 2, then probability of x greater than 1.5 is. So here it is given x follows Poisson distribution with parameter lambda which is 2. So we have probability of x is equal to k, it is given by e raised to minus lambda, lambda raised to k by k factorial. Here we are asked what is probability of x greater than 1.5. This is nothing but 1 minus probability of x less than or equal to 1.5, or it is 1 minus probability of x is equal to 0, 1. So it is 1 minus probability of x is equal to 0 is e raised to minus lambda, lambda is 2. 2 raised to 0 by 0 factorial plus e raised to minus 2, 2 raised to 1 by 1 factorial. So here e raised to 2 is common which can be taken outside. So it is 1 minus e raised to 2 into, inside the bracket we have 2 raised to 0 which is 1 plus 2 raised to 1 is 2. 1 plus 2. Therefore, we get probability of x greater than 1.5 as 1 minus 3 e raised to minus 2. So, the correct option is option D. It is 1 minus 3 e raised to minus 2. The next question, there are 50 telephone lines in an exchange. The probability that any one of them will be busy is 0.1. The probability that all the lines are busy is. So, here we can see that there are 50 telephone lines. And probability that anyone will be busy, it is 0.1. We have to find the probability that all of them will be busy. So here it is a Poisson distribution. So for finding the parameter lambda, first we have to find lambda. So lambda, it is given by n into p. Here n is 50 and p is 0.1. Therefore mean lambda, it is given by 50 into 0.1 which is 5. So here we got lambda as 5. So let us take, let x be the random variable, number of lines that are busy in 50 lines. So x follows Poisson distribution with lambda as the parameter. We got lambda as 5. So x follows Poisson distribution with 5 as the parameter. As a result, we have probability of x is equal to k. It is given by e raised to minus lambda, lambda raised to k by k factorial. Now we need to find the probability that all the lines are busy. That is, we need to find probability of x is equal to 50. It is e raised to minus lambda. Lambda is 5. So e raised to minus 5. 5 raised to 50 by 50 factorial. This is nothing but 5 raised to 50 e raised to minus 5 by 50 factorial. So the correct option is option C. So this is the probability that all the lines are busy. Next question. The mean of probability distribution of number of doublets in 4th rows of a pair of dice. So here we have to find the mean of the probability distribution of the number of doublets in 4th rows of a pair of dice. So here let us take, let x be the number of doublets in 4th rows of a pair of dice. Now the total number of outcomes in a throw of a pair of dice, it is 36. So when we throw a pair of dice, the various outcomes are 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, then 2, 1, 2, 2, 2, 3, up to etc. It goes till 6, 6. And now here the favorable outcomes consists of getting a doublet. So the various doublets that are possible are 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, and 6, 6. So these are the favorable outcomes. As a result, the probability of success P, it is given by the favorable outcomes divided by total number of outcomes. It is 6 by 36 or it is 1 by 6. We have P plus Q as 1. So Q is 1 minus P. It is 1 minus 1 by 6, which is 5 by 6. Now we have taken X as the number of doublets in 4th rows of a pair of dice. So here n is equal to 4. Therefore, X follows binomial distribution with parameters n, p. That is 4, 1 by 6. Here we need to find the mean of this probability distribution. Now we know that in a binomial distribution, the mean it is given by np. This implies mean equal to expectation of x. It is equal to n into p. N is 4 and p is 1 by 6. As a result, it is 2 by 3. So the correct option is option B, 2 by 3. Next question. It is known from the past experience that the number of telephone calls made daily in a certain community between 3 p.m. and 4 p.m. has a mean of 352 and a standard deviation of 31. What percentage of time will there be more than 400 calls made in the community between 3 and 4 p.m. So here we can see that the number of telephone calls made in a community between 3 p.m. and 4 p.m. it follows a normal distribution with mean of 352 and standard deviation of 31. We have to find the percentage of time there will be more than 400 telephone calls made in this community between this time. That is, we have to find probability of x greater than 400. So here mu is 352 and sigma is 31. Now since we have to find probability of x greater than 400, we have to find the z-score when x is 400. When x is 400, z is equal to x minus mu by sigma. It is 400 minus 352 by 31. It is 48 by 31, which is 1.5. Here they have given the value of probability of 0 less than z less than 1.5 as 0.4394, which which can be used. Now we have to find probability of Z, that is X greater than 400. This is probability of Z greater than 1.5. Now probability of Z greater than 1.5, 1.5 is somewhere here. So this is probability of Z greater than 1.5. Here they have given probability of 0 less than or equal to Z less than or equal to 1.5. That is, they have given this area. This area is 0.4394. Now we know that here we have Z is equal to 0. We know that this entire area, it is 0.5. So we can find this particular area, that is probability of Z greater than 1.5 as 0.5 minus probability of 0 less than or equal to Z less than or equal to 1.5. So this is equal to 0.5 minus probability of 0 less than or equal to Z less than or equal to 1.5. So this is 0.5 minus 0.4394, or it is 0.0606. Since we have to express it as a percentage, probability of X greater than 400, it is equal to 6.06%. So the correct option is option D. So this is the percentage of time when there will be more than 400 telephone calls between this time, 3 p.m. and 4 p.m. Now we have the questions from last year's sample question paper. A candidate claims 70% of the people in her constituency would vote for her. If 1,20,000 valid votes are polled, then the number of votes she expects from her constituency is. So here let us take, let X be the number of votes the candidate gets in 1,20,000 votes. Here the candidate claims that 70% of the people in her constituency would vote for her. As a result, the probability of success P, it is given by 70%, or it is 0.7, and N is 1,20,000. So X follows binomial distribution with parameters N, P, 1,20,000, 0.7. So the number of votes she expects, it is nothing but expectation of X. Expectation of X for a binomial distribution is given by N into P. So here N is 1,20,000 into P is 0.7. So this is 84,000. So the correct option is option B, 84,000. Next question, the total area under the normal distributed curve above the baseline, that is integral minus infinity to infinity f of x dx is. So here this is the normal distribution curve. So this entire area, it is nothing but it is equal to 1. So the correct option is option D, which is 1. If we have the case of a discrete probability distribution, then we will have summation pi, that is the sum of their probability, it is equal to 1. If we have a continuous probability distribution like a normal distribution, then the probability density function, it is given by my integral f of x dx, and this total integral minus infinity to infinity f of x dx, it is equal to 1. So this total area, it is equal to 1. Next question, let x denotes the number of hours a student devotes to self-study during a randomly selected school day. The probability that x takes the value x where k is some unknown constant is. So we have the probability of x equal to x as k when x is 0, kx if x is 1 or 2, k into 5 minus x if x is 3 or 4 equal to 0 otherwise. We have to find the probability that the student studies at least 3 hours on a particular day. So here using this information given, we have to find the value of k. So first let us draw the probability distribution table. The various values which x can take are 0, 1, 2, 3, 4, and when it is any other value, the probability is 0. So let us take 0, 1, 2, 3 and 4. The associated probabilities are probability of x is equal to 0, it is k. Then probability of x is equal to 1 or 2, it is k into x. So when x is equal to 1, the probability is k. When x is equal to 2, probability is 2k. Then when x is equal to 3, the probability is k into 5 minus 3. So which is again 2k. Then when x is equal to 4, the probability is k into 5 minus 4, which is k. Now we have the sum of all these probabilities equal to 1, implies the sum of all these k plus 2k plus 2k plus k, it is 7k equal to 1, or from this we get k equal to 1 by 7. Now we have to find the probability that the student studies at least 3 hours on a particular day. That is, we have to find probability of x greater than or equal to 3. It is equal to probability of 3, 4. X is equal to 3, 4. So probability of x is equal to 3, it is 2k. Probability of x is equal to 4, it is k. So it is 2k plus k, which is 3k. Now we already got the value of k as 1 by 7. So this is 3 by 7. So the correct option is option C. Now moving on to the next question. An automatic machine produces 20,000 pins per day. On rare occasion, it produces a perfect pin whose chance is 1 by 10,000. Assuming Poisson distribution, the mean and variance of the number of perfect pins are respectively. So here we have an automatic machine which produces 20,000 pins, and probability of producing a perfect pin, it is 1 by 10,000. So we have to assume Poisson distribution and find the mean and variance of the number of perfect pins. So first let us find lambda. Here n is equal to 20,000 and probability of success, that is probability of a perfect pin, it is 1 by 10,000. So lambda is equal to np, it is 20,000 into 1 by 10,000, which is equal to 2. So lambda is equal to 2. Now if we assume let x be the number of perfect pins in 20,000 pins, then x follows Poisson distribution with parameter lambda. Now we know that in a Poisson distribution, the mean and variance are equal to lambda. Therefore, mean equal to variance equal to lambda. This is equal to 2. As a result, the mean and variance of the number of perfect pins, it is 2, 2. The correct option is option B. Next question, for a Poisson distribution with mean lambda, summation k equal to 0 to infinity e raised to minus lambda, lambda raised to k by k factorial is equal to. Now we know that the sum of the probabilities in a distribution is equal to 1. So in a Poisson distribution, the sum of the probabilities, it is given by summation k equal to 0 to infinity e raised to minus lambda, lambda raised to k by k factorial. So this sum, it is equal to 1. So the correct option is option D. Next question, a TV manufacturer tests a random sample of 6 picture tubes to determine any defect. Past experience suggests that probability of defective picture tube is 0.05. The probability that there is at least one defective picture tube in the sample is. So here we have a random sample of 6 picture tubes which is tested for any defect, and we have probability of defective picture tube is 0.05. We have to find the probability that there is at least one defective picture tube. So here let us assume let x be the random variable, number of defective picture tubes in 6 picture tubes. So here n is equal to 6 and the probability of a defective picture tube, it is given by 0.05. or this is 5 by 100, which is 1 by 20. So here x follows binomial distribution with parameters 6 and 1 by 20. Now from p is equal to 1 by 20, we have q as 1 minus p. Q is equal to 1 minus p equal to 1 minus 1 by 20. It is 19 by 20. So since x follows binomial distribution with these parameters, we have probability of x is equal to r successes as NCR p raised to r q raised to n minus r. Now we need to find the probability that there is at least one defective picture cube. That is probability of x greater than or equal to 1. It is 1 minus probability of x less than 1, or it is 1 minus probability of x is equal to 0. So this is 1 minus NC0. Here n is 6. 6C0, then p raised to 0. P is 1 by 20. 1 by 20 raised to 0, then q raised to n minus r. So q is 19 by 20 raised to 6 minus 0, which is 6. Now this 6C0 is 1. 1 by 20 whole raised to 0 is 1. So this is 1 minus 19 by 20 the whole raised to 6. So the correct option is option B. Next question. A sales promotion company sells tickets for rupees 100 each to win a prize of rupees 5 lakhs. If a person buys one of the 10,000 tickets sold, then his expected gain in rupees is. So here we can see that there is a sales promotion company which sells ticket each for rupees 100 and the price amount is rupees 5 lakhs. So the probability that a person will win the ticket, it is 1 in 10,000, because only one person among these 10,000 will get the prize. We have to find the expected gain in rupees. So let x denote the random variable price 1. So here the various values which x can take are either it can be 0 or it can be 5 lakhs. So probability of getting a price of this 5 lakhs, it is 1 in 10,000. So this is the probability and all the others will lose. So the probability of getting a price of 0, it is 1 minus 1 by 10,000, which is 9,999 by 10,000. So from this, first let us find the expected gain, that is XIPI. So XIPI, it is 0 here and here it is 5 lakhs into 1 by 10,000, which is 50. Therefore, expectation of x, it is 50. But a person is spending rupees 100 to buy this ticket. As a result, the net expected gain, it will be 50 minus 100. 50 minus 100, which is minus 50. So the correct option is option A. So this is the next expected gain in rupees. So it is not a gain, it is a loss. Next question. An insurance company has found that 50% of its claims are for damages resulting from accidents. The probability that a random sample of 10 claims will contain fewer than 2 for accidents is. So here we have an insurance company which finds that half the claims are for damages from accidents. We have to find the probability that in a sample of 10 claims, there will be less than 2 claims for accidents. So let us take, let x be the number of accident claims in 10 claims. So here we have, here n equal to 10 and p is the probability of success. Probability of success is probability of accident claim. Here they have found that 50% of the claims are for accidents. So P is 50%, which is 0.5, or it is half. From this we have Q as half. So here X follows binomial distribution with parameters 10, half. So probability of X is equal to R successes. It is given by NCR P raised to R Q raised to N minus R. We have to find the probability that in a random sample of 10 claims, there will be fewer than 2 for accidents. So we have to find probability of X less than 2. So let us put the values of N, P and Q. So here we have 10 CR, P is half, half raised to R, Q is half, half raised to 10 minus R. So this is 10 CR into half raised to 10. Because here half raised to R plus 10 minus R, this plus R and minus R will go, we are left with only 10. So this is probability of X equal to R. Now we have to find probability that random sample of 10 claims will contain fewer than 2 for accidents. So probability of X less than 2, it is probability of X is equal to 0 and 1. So probability of X is equal to 0 and 1 means here we have to put R as 0 and 1 and add. So this is 10C0 half raised to 10 plus 10C1 half raised to 10. Half raised to 10 is common, which can be taken outside. Inside the bracket we have 10C0 plus 10C1. This is half raised to 10 into 10C0 is 1 and 10C1 is 10. So this is here 1 by 2 raised to 10. It is 1 by 2 raised to 10 into 11. 2 raised to 10 is nothing but 1 by 1024. So this is 11 by 1024. So the correct option is option C. Next question. During a pandemic, 10% of the patients who have the disease get complications. If 100 patients of a locality get infected by the disease, then the standard deviation of the number of patients getting complications is. So here it is given 10% of the patients who have the disease will get complication. There are 100 patients in a locality who got infected. We have to find the standard deviation of number of patients getting complications. So here let us take, let X be the number of patients getting complications in 100 patients. So here we have N as 100. And then probability of a person getting complication, it is 10% or it is 0.1. So probability of a person not getting complication will be 1 minus P, which is 0.9. Now here we can see that X follows binomial distribution with parameters N, P. N is 100 and P is 0.1. As a result, the variance of X, it is nothing but it is NPQ. So it is 100 into 0.1 into 0.9. So this is equal to 9. The standard deviation of X, it is nothing but root of NPQ, or it is root 9, which is 3. So the correct option is option D, which is 3. Next question. An electrical supplier distributor has found the daily demand for fluorescent light bulbs is normally distributed with a mean of 432 and standard deviation of 86. Find the probability that the demand on a particular day exceeds 518 bulbs. So here it is given the daily demand for fluorescent light bulbs. It is normally distributed with mean 432 and standard deviation 86. We have to find the probability that the demand exceeds 518 bulbs. So here they have given mean mu as 432 and sigma as 86. We have to find probability of X greater than 518. So let us find the z-score when x is 518. When x is 518, z is equal to x minus mu by sigma. It is 518 minus 432 by 86. 86 by 86, which is 1. So we have to find probability of x greater than 518. The corresponding z-score is 1, so it is probability of z greater than 1. So if we see the normal distribution curve, we have to find, here we have 1, we have to find this area. So probability of z greater than 1, it is 1 minus, this whole area is 1, it is 1 minus probability of z less than 1. Because we have values only for probability of z less than 1. So this is equal to 1 minus probability of z less than 1. It is 1 minus 0.8413, or it is equal to 0.1587. So the correct option is option A, 0.1587. So this is probability of x greater than 518. Next question, the value of mortgage loans made by a certain bank is normally distributed with mean of 36 lakhs and standard deviation of rupees 12 lakhs. The probability that a randomly selected mortgage loan is less than 54 lakhs is. So here everything is given directly. The value of mortgage loan, it is normally distributed and the mean is given 36 lakhs and a deviation is 12 lakhs. We have to find probability that a randomly selected loan is less than 54 lakhs. So here mu is 36 lakhs and sigma is 12 lakhs. Now we have to find probability of x less than 54. For that, let us find the z-score. When x equal to 54, z equal to x minus mu by sigma. So it is 54 minus 36 by 12. 22 by 12, which is 1.5. Now probability of x less than 54. It is equal to probability of z less than 1.5. This is equal to 0.9332, or it is 93.32%. So the correct option is option B. Next question, a river passing near a town floods it on an average twice every 10 years. Assuming Poisson distribution, find the probability that the town faces flooding at least once in 10 years. So here the average is directly given. It says a town floods average twice every 2 years. So the average is 2. Assuming Poisson distribution, we have to find the probability that the town floods at least once in 10 years. So here let us take, let x be the number of times the town floods in 10 years. Here lambda is given as 2. So x follows Poisson distribution with parameter lambda. So probability of x is equal to k. The probability distribution function of x, it is given by e raised to minus lambda, lambda raised to k by k factorial. Now we need to find probability of x less than or x more than or equal to 1. It is 1 minus probability of x less than 1. It is 1 minus probability of x is equal to 0. It is 1 minus e raised to minus lambda. Lambda is 2. 2 raised to 0 by 0 factorial. So it is 1 minus e raised to 2. E raised to 2, it is given as 0.1353. This is 1 minus 0.1353. This is 0.8647. So the correct option is option D, which is 0.8647. Next question, the height of a certain species of plant is normally distributed with mean of 20 centimeter and standard deviation of 4 centimeter. What is the probability that the height of a plant chosen at random lies between 10 centimeter and 30 centimeter? So here it is given the height of a certain species of plant. It is normally distributed with mean 20 and standard deviation 4 centimeter. We have to find the probability that the height of a plant which is chosen at random, it lies between 10 and 30 centimeter. So we have to find the z-score for x is equal to 10 centimeter and x is equal to 30 centimeter, and then we can find the associated probability easily. So here mu equal to 20 centimeter and sigma equal to 4 centimeter. And we can find the z-score as z is equal to x minus mu by sigma. When x is equal to 10 centimeter, z is equal to 10 minus 20 by 4. It is minus 10 by 4, which is minus 2.5. And when x is equal to 30 centimeter, z is equal to 30 minus 20 by 4. It is 10 by 4, which is plus 2.5. This is the z-score. So when x is 10, z is minus 2.5, and x is 30, it is plus 2.5. We need to find the probability of 10 less than x less than 30. It is probability of minus 2.5 less than z less than 2.5. Here we have probability of 0 less than z less than 2.5 given as 0.4938. So if we consider the normal distribution curve, the standard normal distribution curve, here we have 0, here we have 2.5, and here we have minus 2.5. We need to know this entire area, but here the value given is the area of this part, that is from 0 to 2.5 they have given. So this entire area will be 2 times this area. So this is equal to 2 into probability of 0 less than z less than 2.5. So it is 2 into 0.4938, or it is 0.9876. So the correct option is option C, which is 0.9876. So these are the various questions from last year's sample paper. And now we will see the questions from this year's sample question paper. So here for the following questions, 2 statements are given, one labeled assertion A and the other labeled reason R. Select the correct answer to these questions from the codes 1, 2, 3 and 4 as given below. So code 1 says both A and R are true and R is the correct explanation of assertion. Code 2 says both A and R are true but R is not the correct explanation of the assertion. 3, A is true, R is false. 4, A is false but R is true. So we have the assertion reason question given. Assertion, Kuhu and Beena are 2 equally capable badminton players. Probability that Beena will beat Kuhu in 3 games out of 4 is 25%. So this is the assertion given. This we have to check. Reason, probability of R successes in n trials denoted by probability of x equal to R is given by NCR P raised to R Q raised to n minus R equal to 0, 1, 2 up to etc. n, where P denotes success and Q denotes failure in each trial. So here this is the reason which is given. Here we can see that the reason is true, that is in a binomial distribution. The probability of R successes, it is given by this formula. Now let us check whether the assertion is true or not. Let us take let x be the number of games Beena wins in 4 games. So here n is equal to 4. And then here it is given Kuhu and Beena are 2 equally capable badminton players. So here we have probability of success P as half since they are equally capable, probability of Bina winning is half, and probability of Bina losing is also half. Q is equal to 1 minus P, it is half. So X follows binomial distribution with parameters 4 and half. Now we have to find probability of X is equal to 3. That is probability that Bina will beat Kuhu in 3 games out of 4. Probability of X is equal to 3. It is, here we have to put N as 4, R as 3 and PQ as half. So it is 4C3 half raised to 3 half raised to N minus R, 4 minus 3. So it is half raised to 1. Now 4C3 is 4 into, here we have 1 by 8 into 1 by 2. So this is 1 by 4, or it is 0.25, which is 25%. So here we can see that the assertion is also true. That is the probability that Bina will beat Kuhu in 3 games out of 4. It is 25%. So here the assertion is true, the reason is also true, and the reason is the correct explanation of the assertion. So the correct code is what? Which corresponds to option A. So the correct option is option A. Moving on to the next question. This is a 5-mark question. It is known that 3% of plastic buckets manufactured in a factory are defective. Using Poisson distribution on a sample of 100 buckets, find the probability of 0 defective buckets. At most one bucket is defective. Use e raised to minus 3 as 0.049. So here we can see that 3% of plastic buckets manufactured in a factory are defective. We have to use Poisson distribution. In a sample of 100 buckets, we have to find the probability of each of these. So probability of defective bucket, P, it is given as 3% or it is 3 by 100. And then the number of buckets N is 100. We have lambda is equal to NP, which is 100 into 3 by 100 equal to 3. Now let us take let X equal to number of defective buckets in a sample of 100. So here X follows Poisson distribution with lambda as the parameter, which is 3. So from this we have probability of X is equal to K. It is e raised to minus lambda raised to K by K factorial. Now probability of no defective bucket. It is probability of X is equal to 0. It is e raised to minus lambda. Lambda is 3. 3 raised to 0 by 0 factorial. So 3 raised to 0, 0 factorial are all 1. E raised to minus 3 is given as 0.049. So this is the probability of no defective bucket. Next we have probability of at most one defective bucket. Probability of at most one defective bucket. It is probability of X less than or equal to 1. So it is probability of X is equal to 0, 1. So it is e raised to minus 3, 3 raised to 0 by 0 factorial plus e raised to minus 3, 3 raised to 1 by 1 factorial. Here e raised to minus 3 is common, which can be taken outside. Inside the bracket we have 3 raised to 0 is 1 plus 3 raised to 1 is 3. E raised to minus 3 is 0.049. So it is 0.049 into 4. This is 0.196. So probability of at most one defective bucket. It is 0.196. So here finding the mean, writing what is X, writing the formula, all these carries 1 mark. Then the first subdivision, that is finding the probability of no defective buckets, carries 2 marks. And the second subdivision, that is finding the probability of at most one defective bucket. This carries 2 marks. A total of 5 marks for this question. This 1 mark, 2 marks, 2 marks. Next question, in a math aptitude test, students' scores are found to be normally distributed having mean as 45 and standard deviation 5. Here what percentage of students have scores more than the mean score between 30 and 50. This is also for 5 marks. So here we can see that the student scores are normally distributed with mean 45 and standard deviation 5. We have to find the percentage of students who have scores more than the mean score and whose scores are between 30 and 50. So let us take let x is equal to scores of the student. So here mu is equal to 45 and sigma equal to 5. So z is equal to x minus mu by sigma. It is x minus 45 by 5. Now we'll see the first subdivision. That is, we have to find the percentage of students who have scores more than the mean score. That is when x is equal to mu. That is when x is equal to 45, z is equal to 45 minus 45 by 5, which is equal to 0. So probability of x greater than 45 equal to probability of z greater than 0. So if we see the standard normal distribution curve, here we have z is equal to 0. So probability of z more than 0, it is this half of the curve. So this is 0.5 or it is 50%. As a result, 50% students scored more than the mean score. And now we have the percentage of students who have scores between 30 and 50. So the second subdivision, when x equal to 30, z equal to 30 minus 45 by 5, it is minus 15 by 5, which is minus 3. And when x is equal to 50, z is equal to 50 minus 45 by 5. It is 5 by 5, which is 1. So probability of 30 less than x less than 50. It is equal to probability of minus 3 less than z less than 1. So here probability of minus 3 less than z less than 1 is, here we have minus 3, this is 0, and somewhere here we have 1. So we have to find this entire area. Now this area can be calculated as probability of z less than 1, this whole thing, minus this part, probability of z less than minus 3. So this is probability of z less than 1 minus probability of z less than minus 3. Probability of z less than 1 is 0.8413 and probability of z less than minus 3, it is 0.0013. So this is 0.84 or it is equal to 84%. Therefore, 84% students scored between 30 and 50 marks. So here again writing what is x and writing the formula for z score, all these carries 1 mark. Then finding the answer for the first subdivision, it carries 2 marks, and then finding the answer for the second subdivision carries 2 marks. So a total of 5 marks for this question. The last question, it is a case study question. According to an educational board survey, it was observed that class 12 students apply at least 1 to 4 weeks ahead of college's application deadline. Let x represent the week when an average student applies ahead of a college's application deadline, and the probability of student to get admission in the college, that is probability of x equal to x, is given as follows. So probability of x equal to x is kx by 6 when x is 0, 1 or 2. It is equal to 1 minus k into x by 6 when x is 3. It is kx by 2 when x is 4. It is 0 when x greater than 4, where k is a real number. Based on the above information, we have to answer the following questions and we have to show steps to support the answers. The The first subdivision is we have to find the value of k. So here we can see that x, it represents the week ahead of, that is the number of weeks ahead of a college's application deadline, and the associated probability, it is given here. So first we have to find k, then we will do the other subdivisions one by one. Find the value of k. So here we have the various values of xi and the associated probabilities. The various values which x can take are 0, 1, 2, 3, 4, and for more than 4 it is 0. So we need not worry about the case when x is more than 4. When x is 0, the probability is k into 0 by 6, which is 0. Then when x is 1, the probability is k into 1 by 6, so it is k by 6. Then when x is 2, it is k into 2 by 6, so it is 2k by 6. And then when x is 3, it is 3 into 1 minus k by 6, or it is 3 minus 3k by 6. And next we have when x is 4, it is 4k by 2. 4k by 2. Now we know that summation pi is equal to 1. So from that we can find k. K by 6 plus 2k by 6 plus 3 minus 3k by 6 plus 4k by 2 plus 0 equal to 1. So here if we take the LCM as 6, here we will have k plus 2k plus 3 minus 3k, then plus 12k equal to 1. Here k plus 2k minus 3k, all these will go. We will get 3 plus 12k equal to 6, or 12k equal to 3. K is 3 by 12, which is 1 by 4. Therefore, k equal to 1 by 4. So this is the value of k. That is the first subdivision. It carries 1 mark. The second subdivision. What is the probability that Sonali will get admission in the college given that she applies at least 2 weeks ahead of application deadline? So here we have to find the probability that Sonali will get admission if she applies at least 2 weeks ahead of the application deadline. That is, we have to find probability of x greater than or equal to 2. So probability of getting admission applying at least 2 weeks ahead of application deadline is probability of x greater than or equal to 2. It is 1 minus probability of x less than 2. So it is 1 minus probability of x is equal to 0, 1. So it is 1 minus, we got k as 1 by 4. So when x is equal to 0, this is 0. When x is equal to 1, it is k by 6. It is 1 minus k by 6. It is 1 minus k is 1 by 4, 1 by 24. Since k equal to 1 by 4. So this is, if we take LCM, it is 24 minus 1 by 24, which is 23 by 24. So this probability, it is 23 by 24. Now moving on to the next question. Calculate the mathematical expectation of number of weeks taken by a student to apply ahead of college's application deadline. So here we have to find the expectation of x. This carries 2 marks. So here let us take that x is equal to week applied ahead of the application deadline. So the various values which x can take are, the student can apply 1 week ahead or 2 weeks ahead or 3 weeks ahead or 4 weeks ahead. So let us take this as xi. Then probability of x equal to xi, which is pi. We already got the value of k as 1 by 4. So probability of x is equal to 1, it is k into 1 by 6. So it is 1 by 4 into 1 by 6, which is 1 by 24. Then probability of x is equal to 2 is k into 2 by 6. So it is 2 by 6 into 1 by 4, which is 1 by 12. Then probability of x is equal to 3 is, here it is 1 minus k into 3 by 6, or it is 1 minus k is 1 by 4, 1 minus 1 by 4 into 3 by 6 is 1 by 2. So this is 3 by 4 into 1 by 2, which is 3 by 8. So this is 3 by 8. Then probability of x is equal to 4 is k into 4 by 2. So it is k into 4 by 2, which is 2k. So it is 2 into 1 by 4, which is half. So this is half. So these are the various probabilities for each of the value of x. Now we have to find expectation of this x. We know that expectation of x is summation xi pi. So let us find xi pi. So here we have 1 into 1 by 24, 1 by 24. Then 2 into 1 by 12, it is 1 by 6. Then 3 into 3 by 8 is 9 by 8. And 4 into half is 2. Now expectation of x, all these are rough. It is summation xi pi. So it is 1 by 24 plus 1 by 6 plus 9 by 8 plus 2. So for this the LCM is 24. 24 into 1 plus 4 plus 27 plus 2. So this is 32 by 24 plus 2, or it is, this goes, it is 4 by 3, or it is 4 by 3 plus 2 is, it is 10 by 3. So it is 3 1 by 3. So expectation of x, it is 3 1 by 3. 3 1 by 3 weeks. This is the expectation of x. That is mathematical expectation of number of weeks taken by a student to apply ahead of college's application deadline. Now this carries 2 marks. Then we have the last question. To promote early admissions, the college is offering scholarships to the students for applying ahead of deadline as follows. Rupees 50,000 for applying 4 weeks early, 20,000 for applying 3 weeks early, 12,000 for applying 2 weeks early, and 9,600 for applying 1 week early. What is the expected scholarship offered by the college? Again, this question carries 2 marks. It has an internal choice. So it is the or part of the same question. So here let us take, let x is equal to scholarship money awarded for the week applied in before the deadline. So the various values which x can take are 9,600 if applied 1 week early, then 12,000 if applied 2 weeks early, 20,000 if applied 3 weeks early, and 50,000 if applied 4 weeks early. So the probabilities for the various weeks applied ahead, the probabilities that we just now found. It is 1 by 24, then 1 by 12, then 3 by 8 and half. So here this is xi and this is pi. Here we have xi pi as 9,600 into 24 into 1 by 24. So it is 9,600 divided by 24, which is 400. Then 12,000 by 12, which is 1,000. Then 20,000 into 3 by 8. It is 3 into 2,500. 50,000 into half. It is 25,000. So we have expectation of x as 400 plus 1,000 plus 7,500 plus 25,000. So this is equal to 33,900 rupees. So this is the expected scholarship offered by the college, which is 33,900. So these are the various questions from this year's sample question paper on chapter 4 probability distributions. So we have seen the previous questions and last year's questions from the last year's sample question paper and questions from this year's sample paper on probability distributions. I hope this video was useful for you. If you have not subscribed to my channel, please subscribe. If you find this video useful, share it with your friends. Thank you for watching.